So we've looked at our London dispersion, which are the very weak ones, the weakest that we can get, where all molecules have. We've looked at ionic crystal, where we only see ions. We've looked at network covalent, where we've got 5 specific ones. And so now we're going to start looking at dipole-dipoles, and then we've got hydrogen bonds as a specific type of dipole-dipole. Okay, note that hydrogen bonding is stronger than dipole-dipole. However, if we look at dipole-dipole first, then hydrogen bonding will be a little bit easier after. So our dipole-dipole forces are going to be fairly strong. They're going to be between polar molecules. And so again, a polar molecule is where we've got that partial charge. And so that electronegativity difference of 0.5 to 1.7 with our polar bonds, our polar covalent bonds. There's going to be a permanent dipole. So it's not temporary, not momentary. It's not being influenced by something that's bringing close together, but it's always got those partial charges. And so, for example, if we look at hydrogen and chlorine, where we have a partial positive charge and a partial negative charge, we've got 2.1 and 3.0. It fits within that range. We would have a dipole-dipole. So this interaction here between the partial positive of the hydrogen and the partial negative of the chlorine is going to be that dipole-dipole. Okay, so if we're looking around, we've got, there's always, it's always lining up. So if we, here, if our negatives are our chlorine molecules and we see these little balls here as our positive, you're seeing that electron density that's being shifted towards that partial negative and partial positive. And so between that partial positive and that partial negative, that's where we've got that dipole-dipole attraction. If we're looking between the two negatives, partial negative, that's where we're going to see that repulsion. So dipole-dipole forces are fairly high melting and boiling points since the intermolecular force is fairly strong, especially with smaller polar molecules. So know that although they're fairly strong, they're in that mid-range, knowing that they're not as strong as that ionic crystal, but they're also not as weak as that London dispersion.